I'd like to say a couple of words in background about both the library search as well as the library structure itself. So first, the library search algorithm is integrated into MassHunter. And the searching algorithm against, of course, the library can screen the candidates using a fast similarity metric. And I think you'll be quite impressed at the speed at which it does that searching. It produces a match score using a weighted dot product of comparing the target and the reference spectra together. And there are, of course, generalizations. This could be used with MS-MS spectra as well, and as mentioned, it could also be extended to a higher mass accuracy approach. The library search takes deconvoluted spectra, which have been created from running the deconvolution algorithm, and underneath the TIC there could be a group of ions that fit a model peak shape. We're going to take that spectra from those group of ions, and that deconvolved spectrum is then going to be run using an index and then a dot product search to match up against the library entries. And the best matches, the ones which show the best match factor quality, will then be added to the unknowns analysis and come up as candidates. So let me paraphrase here. The deconvoluted pure spectrum information is used to determine whether the component can be identified as one of the compounds represented in a reference library. And from a practical point of view, this is often used in identifying compounds using GCMS scan data, and it helps to maintain a level of reliability in identifying these compounds correctly. Let's mention the library search parameters. Several which are useful are first to limit the number of hits that are returned per target. There is, for example, very useful to say what the minimum match score is that you want returned from the candidates. And then retention time penalties, if you have retention times associated in your library. For example, if you're using retention time locking and you have fixed retention times, these can associate penalties with the retention time window. And in a separate section, I will discuss the retention time calibration using retention time indices as a mechanism to also do a filtering or criteria based on the library searching. It's worth mentioning that the library database has a schema associated with it. So let me point out a couple of columns in the schema. First, obviously, there's the compound name, and associated with that is a spectrum. So the spectrum is stored here in base 64 encoded format. And for MS-MS, there is the definition of the precursor ion, which is called selected M over Z. And for large databases, there is an MZ signature, which is basically an index that's used to do faster searching before you do the dot product matching. Here is an example of the definitions of the different columns that are in the schema. And for example, the mole file, here's the format and example that discusses what's in that text mole file, which is used to draw the molecule itself in the library editor.